Hi, this is Harry, and I'm gonna give a brief introduction about our final project in the Big Data Analytics class. So, our project name is Analyzing and Prediction of Columbia Students' Figures. And we have been learning to use various tools related to big data, such as Hadoop, Maut, Spark, and all kinds of algorithms such as clustering, recommendation, prediction to deal with different datasets and get the results we want. But we tend to ignore what's underneath, so we decided to implement the algorithm by ourselves and to gain a deeper understanding of why this algorithm works. So the most important thing in this project is not about practical use, but about the research and understanding on the algorithm. We need to analyze why the algorithm works and from mathematics point of view. Do calculation, reduction, iteration to get the right algorithm and to prove the correctness of the algorithm. We tend to achieve more than one algorithm, so the comparison of the algorithm is needed. After figuring out the algorithm mathematically, we need to implement it by code and run it in MATLAB. So the next important thing is to write the MATLAB code. To get a result, we also need dataset to be input of the algorithm. So the algorithms related to this project is expectation maximization, variation inference, k-means, probit regression. And of course, we need the dataset. So we collect this dataset through social media. So it consists of 800 samples from Columbia students, in which 400 are females, 400 are males, and it has the information of the students' height, weight, age, GPA, and gender. We will do clustering by two different algorithms and compare the results of them. Then we will do prediction algorithm based on the dataset. After all, we will try to find out the relationship among students' height, weight, age, GPA, and gender, and will visualize this result by MATLAB. Then I will let my teammate Bao Kunchen to introduce the algorithm that is implemented in this project.
Hi everyone, I will introduce the algorithm we use and present to you some results. First, we do the clustering with the Gaussian mixture model. We have a data set with n data, with each data has a d-dimensional. And the Gaussian mixture model is assume the probability density of the data. That is a weight sum of k Gaussian distributions. It has such a formula where pi is the probability distribution on Gaussians, and mu g and lambda g is the mean and precision of the gth Gaussian. We can think pi g as the fraction of the data that is produced by the gth Gaussian. The first algorithm we use is the expectation maximization algorithm. There are two steps in such an algorithm. First, we need to find a latent variable which can keep the marginal distribution unchanged. Second, we need to find an objective function. Then we maximize this function to get the parameters we need. In the first step, we find such a variable C and set its distribution to be the posterior. And in the second step, we calculate the likelihood function to be the one that we want to maximize. Here's the result for the maximization over the three parameters, pi, mu, and lambda. The second algorithm we use is the variational inference algorithm. Still, for the three parameters, we first define three prior orders for them. We choose such prior orders just for convenience to compute. Then we calculate the posterior distribution, and here's the result for the three parameters. Now I will present you some results for the clustering. Here's the result for the height, weight, and age. We have 4 clusters, so the 4 black circle represents the center for each cluster. Here's the result for the height, weight, and GPA. Still 4 clusters with 4 centers. Here's the result for the height, weight, and gender. This is actually a 2-dimensional clustering. The 0 face is the female data, and the 1 face is the male data. And here is the 2-dimensional figure. This is the height, weight for the female data, and this one is the height, weight for male data. We can do clustering for the 5-dimensional vector, but to construct a figure, we can only do a 3-dimensional figure here. Okay. The second thing we did is the prediction with probability regression. We have a data set x and y, where x is a feature vector with a d dimension, and y is 0 or 1 is a class label. What we want to do is to predict the value of y for a new x. We have such an assumption that y is a Bernoulli distribution, which has an unknown variable w. W is a Gaussian distribution. We process the data as we use the height, weight, GPA, and age to construct the x as the feature vector, and we predict the gender as 0 or 1. Here's the EM algorithm for probability regression. In the first step, we still find the latent variable. And in the second step, we calculate the posterior distribution instead of the likelihood, which is slightly different from the previous EM algorithm. Here's the result for the calculation for the parameters. Okay, that's all. Thank you.